We do have two new theorems here. Theorem 9.4 is the composition theorem. This one's fairly straightforward, because what we should notice is that all of the transformations we've looked at already, our translations, our rotations, our reflections, they're all isometries. They give us congruent figures. So what happens is, even if we do multiple transformations that are isometries, we'll still end up with a congruent figure. Theorem 9.4 tells us the composition of two or more isometries is an isometry. So no matter what, if our transformations are all giving us congruent figures, then the final figure will still be congruent to the original. So no matter how many times I reflect, rotate, translate, and those are your isometries, reflections, rotations, and translations, I still end up with an isometry. The next theorem is a little bit trickier, so I want you to really take a moment to understand this. Theorem 9.5 is reflections in parallel lines theorem. It tells us if lines K and M are parallel. So we're going to construct two parallel lines here. Then the reflection in line K, okay, we're going to take a triangle and we're going to reflect it in line K. Followed by a reflection in line M. Okay, so same triangle, now we're reflecting it again. And we see that going from green to red is the same as a translation. So a double reflection in parallel lines is the same as a translation. Let's try an example with this. Below is a composition of two reflections in parallel lines. So these two lines are parallel. Give the single transformation that would map triangle ABC to triangle A double prime, B double prime, C double prime. So take a moment, try to figure this one out on your own first, and resume the video when you're ready to check your solution. Okay, so first of all, we know if we're doing a double reflection in parallel lines. So this is a double reflection in parallel lines. This is the same as a translation. We're translating the blue figure to this purple one. So what we want to do is look at the coordinates. We can look at A, which is at -2, 0 right now, and A double prime, which seems to be at about, oh, I made this one hard on you guys. I'm sorry. 1.2 comma -6.5. So what we see is to get from A to A double prime, in the x coordinate we are adding 3.2, and for the y we're subtracting 6.5. So we're taking xy and we're mapping it to x plus 3.2 and y minus 6.5. That is your final answer, or you could write this as a vector of 3.2 comma -6.5. Either answer is acceptable and is accurate. What you should see is if you were to write the coordinates for C to C double prime and B to B double prime, you'll see the same translation. Again, x plus 3.2 and y minus 6.5. Alright, we have another new theorem.